Hi, so my presentation name is Synthesis of NH sulfoxamines. The title of my paper is Synthesis of NH sulfoxamines from sulfides using ammonium carbamate and benzene to transfer NH and O. So below that is my general reaction. The intermediates are added to the starting structure and then add nitrile sulfonyl and azonide. My reaction paper in the organic synthesis does not state anything about the reaction being dangerous at any scale, but it is safe at least a 5-gram scale, which is what they did in their reaction. The paper says to take standard precautions like any other reaction, and the reaction is also fairly inexpensive, and there are not many different chemicals used in it. The checking process. The checkers did add some comments in the notes of the paper. They added a second run of the reaction on a similar scale, provided 5 grams, 62% of the desired product. And they added the TLC plate for the reaction. The first set of plates is with the product with the hexanes as the eluent. The first dot in the first TLC plate is the starting product, and the second dot is the final product. The second plate, which it says B on it, is the same thing, but 40% ETOAC in hexanes is used as the eluent. And the first dot is still the starting product, and the second dot is still the ending product. This is generally used to show if you have the desired chemicals in your product or if you did not. So there are 3 different major apparatuses used in this reaction. The first picture is of a 500 milliliter one-necked round bottom flask. The second one is a picture of a 1 liter separational funnel. And the last picture is of a 250 milliliter one-necked round bottom flask. So reagents and starting material. At the very beginning of the reaction, the initial condensation of ammonia with the hypervalent iodine reagent leading to an immunoiodinane, which undergoes oxidation to form a highly reactive iodonitrine. There are no special purifications of any chemical at the beginning of the reaction, but the 4-bromophenol methyl sulfane is the limiting reagent with 1 equivalence, and the diacetoxyiodo is the excess reagent with a 2.5 equivalence. It is important to have excess reagent because when performing the reaction, because you need enough to do the reaction of the product for the reaction to happen, and you ideally want extra in case anything happens, as well as it is a part of the reaction. So this is a reaction procedure. The first step is to add a 250 milliliter one-necked round bottom flask with a Teflon coated oval stir bar is put into a water bath at 25 degrees Celsius. 70 milliliters of MEOH is added to the flask as well. Then you stir. 7.11 grams of the 4-bromophenol methyl sulfane and 5.47 grams of ammonium carbamate are added using a powder funnel. The next step is to add 28.18 grams of the diacetoxyiodo benzene is added in total but split into 4 different portions and added over a period of 5 minutes, allowing for controlled decarboxylation. The fifth step is to stir the reaction at 25 degrees Celsius for 3 hours. And last step is over time, the reaction should turn from a colorless to a pale yellow, as you can see in the picture. The picture where it says A is everything being added, B is completely colorless, and C is the pale yellow. The reaction workup. So this is what they do to actually get the product after. So what they do first is they evaporate the solvent under reduced pressure, and a yellow slurry is formed. Um, the product is diluted with 150 milliliters of ETOAC and 100 milliliters of saturated NaHCO3 and stirred for about 30 minutes. Stirring for 30 minutes will neutralize the acetic acid formed during the reaction. The resulting solution is transferred to a 1 liter separatory funnel, and the flask is rinsed with ETOAC with 100 milliliters 3 different times. The layers are separated, with the organic layer is washed with distilled water. The combined aqueous is extracted with the ETOAC. The organic layer is extracted with HCl. The acetic layers are combined and transferred to a clean separatory funnel, washed with CH2Cl3, Cl2, then basified to a pH of 12 with NaOH and extracted with CH2Cl2. The combined factors are dried with anhydrous Na2SO4. The solution is filtered through a 7 centimeter glass funnel plugged with cotton wool, and the Na2SO4 is washed with CH2Cl2 in a 500 milliliter round bottom flask. The solvent is evaporated under reduced pressure and then placed under high vacuum for 18 hours to remove any residual solvent. And then the product is formed. So for purification, the purification of the product was done through NMR. The chemist running the reaction calculated the purity by doing a quantitative 1H NMR with a reaction delay of 30 seconds using 21 milligrams of trimethoxybenzene. The purity came to 99% as well. So for characterization and proof of purity, the chemist running the reaction used the TLC plate and NMR to make sure that the chemicals in the product were the desired chemicals in the product, that there was nothing else in there, and to see how pure the product was what the NMR was for. So safety note and hazard, there's no immediate dangers in this reaction. In the paper, it stated no immediate threats, no major chemical explosions or anything. All the chemicals used in this reaction are fairly safe. They all only require standard precautions, and this reaction is safer than most. So the discussion section, the initial condensation of ammonia with the hypervalent iodine reagent leads to an iminoiodinane, which undergoes oxidation to form a highly reactive iodonitrine. The iodonitrine reacts directly with the sulfide to form the corresponding sulfilamine that reacts with the O donor, ending up with the formation of a sulfane nitrile that converts into the corresponding NH sulfoxamine. Well, the nitrogen sulfide is combined with the pH ion to form this structure. Water is then added to form nitrosulfonyl azonide with the hydrogen, and the hydrogen is moved from the oxygen to the nitrogen. So the authors, the first bullet pointer is Ellie and Yoon. They checked the paper after, and Ariana is all these people performed the reaction at the corresponding university next to it. Ariana performed it at Kyoto University. Morrow was at University of Bari. Edward was at Imperial College in London. Another Imperial College in London. Zong was at Imperial College in London. Leonardo was at the University of Bari. Dr. James Bull was at the University of Montreal. And Renzo was at the University of Manchester. These are my references.